This is for specialist maths. It comes out of 9F as question number 6 to do with related rates. So a water tank of uniform cross-section area A. So I'm going to call this area here of the surface area of the tank A, and that's the surface area. So that's going to be centimetres squared. And what else do we have happening here? It's filled by Q litres of water every minute. So Q litres per minute goes in. The tank has a small hole at the base of which water is leaking at a rate of kH litres per minute, when H is the height of the water. Initially, the depth of the water is HO in centimetres. So at time equals 0, H equals HO. Okay, so we have a unit issue. We have centimetres at our height, centimetres for A, but we have litres for the volume. So I'm going to make a conversion, and 1 litre is 1,000 cubic centimetres. So what I've got going in is actually 1,000 Q, and what I've got going out is kH times 1,000, and now we have centimetres cubed per minute, and that's centimetres cubed per minute. Construct a differential equation for the change of height. Well, because it's a uniform top and bottom and it's a cylinder, the volume will be A times height, which means height is volume divided by A. So the rate going in will be the volume going in, which is 1,000 Q, that's going to be divided by A, and what's going out should be 1,000 kH divided by A, which gives me 1,000 on A times Q minus kH. So there's my differential equation. So T should be the integral dH of A on 1,000 Q minus kH. One on Q minus kH, which means T will equal, I need in the numerator, I need a negative K, therefore I need a negative K down there. So I've got negative A on 1,000 K log base E of Q minus kH plus some constant C. And I know that at time 0, of Q minus KHO plus C. Therefore, C equals A on top of 1,000 K log base E of Q minus KHO, which means that T equals A on top of 1,000 K log base E, this is on top, Q minus KHO on top of Q minus KH. Now where it says solve the differential equation, K has to be bigger than that, therefore that's going to be positive. I could solve it for H, or I could solve it for T. Both of them are an acceptable equation, so I'm going to stop there. And now it's telling me what is the depth, find the time taken for the depth to reach that. So if I get a copy of that, and paste, so to find the time. So that's, I'm going to leave T equals A on top of 1000 K log base C of Q minus K HO over Q minus K times Q plus KHO on 2 equals A on 1000 K log base C of Q minus KHO on top of Q minus KQ on 2 plus that's 2K, which means that K is going to cancel with that K there, and that K isn't there. So then I've got minus times a plus, so then I've got minus KHO on 2. So I've got A on top of 1000 K log base C of Q minus KHO on top of Q minus Q on 2 is Q on 2 minus KHO on 2, which is A 1000 K log base C of Q minus KHO on top of Q minus KHO on 2, which will give me log base C of 2. And that's going to be the time.